Okay, so we are going to do a review today about cumulative frequency, and the big idea about cumulative frequency is that you're looking at how many items are less than or equal to the group that you're kind of talking about, and so that frequency is accumulating each time. And so the easiest way to understand this topic is to look at some examples. So this problem says a fisherman catches 200 fish to sell. He measures the lengths of these fish, and here are our results. So we know here are the different groupings, and here are how many fish are in each group. And so to calculate an estimate for the standard deviation of the lengths of the fish, this is a good review for many people, we are going to use the mid-interval values. And so the mid-interval value is just the middle value, the median. So we have 5 here, 15 here, 25 here, 35, 50, and the middle value between 60 and 75 is going to be 67.5. And between 75 and 100 is going to be 87.5. So it's literally just the median, or you could also call it the mean of the two boundaries. And so once you do that, you just plug in each of these into X into your list, and each of these in for your list 2, and you're going to go ahead and use a calculator to calculate the standard deviation. In order to use your calculator for that, you put it into list 1, list 2, you go to stat, move over to calculate, and then you're going to choose one variable, stats. Make sure that where it says list you have L1, and that where it says frequency list you have L2, and then you're going to hit calculate, and you're looking for the little symbol that looks like this, and when I round that to 3 sig figs, it is 19.78, which rounded is 19.8 as our standard deviation. Okay, so looking at the cumulative frequency diagram, it shows it to us. It asks us to find the interquartile range. Remember that the interquartile range is just your upper quartile, which is your 75th percentile, minus your lower quartile, which is your 25th percentile. So we're going to use 0.75 and 0.25. So we want to find out what is the length of the fish who is at the 75th percentile. So there's total, we can see, because 200, we can see that the highest value of this graph is at 200. So we're going to multiply 200 times that 0.75. And that gives us that we're trying to find the 150th fish. Okay, so that's not the length of the fish, right? That wouldn't make any sense. We didn't have any fish above 100. And then we are going to do the same thing here. We're going to multiply the 25 times, the 0.25 times 200. And when we do that, that gives us the 50th fish. So we're looking for, if we lined up all the fish in order from smallest length to highest length to greatest length, the 50th fish would be a quarter of the way up, and the 150th fish would be 3/4 of the way up. So we're going to go on the left side here and find 50 and 150, and we're going to trace it over. So as I do that, trace it over and then down, and I see that the length of that fish is about 15 centimeters. And then I'm going to do that again for the 150th fish. So I follow that over and then down. And you guys would be able to do a better job on your paper. I see that that's about 40 centimeters. And the interquartile range is the 40 minus the 15. And so that gives us 25 as our IQR, 25 centimeters. Okay, the next problem says, given that 40% of the fish have a length of more than K centimeters, find the value of K. So one thing about percentiles is that we're always talking about the percent that are less than that. So if we use 40% of 20, we're talking about the lower 40% of the lengths of the fishes. So really we're talking about, if we're talking about 40% have a length above K, then we're talking about 60% that have a length below K. So we're going to go ahead and use that 60th percent. And we're going to say, okay, well, what is the 60th percentile fish? So 60% of 200. And that gives us the 120th fish has a length of, I'm sorry, the 120th fish is the 60th percentile fish. So we're going to go ahead and look at the 120th fish. And as we come down, that is 30 centimeters. Okay, so the next part of this problem says that the fisherman is going to classify these fish as small, medium, or large with the following classifications. Small fish being less than 20 centimeters, medium being greater than or equal to 20 but less than 60, large being greater than or equal to 60. So it says write down the probability that a fish is small. So we're really trying to find out how many fish are small, and then we can find out the probability of that. So small fish have a length of less than 20. So 20 centimeters is our unit. So we're looking along this x-axis, and we're looking for 20. And so we're going to go ahead and take that 20 and follow that up and over. And so when I do that, I did not do a very good job with that, so you'll have to forgive me. But when you follow that 20 up and over, that is a 70 fish that are length of 20 or less. So if that's 70 fish, it asked us for the probability of it being small. That's 70 out of total 200, which we know we can reduce to 7/20ths as our probability. Then it says the cost of a small fish is $4, so we can see that in here. The cost of a medium fish is 10 and a large is 12. So it asks us to complete the table. Well, we just found out the probability that a fish is small. It was 7/20ths, which is the same as 0.35. So I can go ahead and plug that in right there. It's telling us the probability of it being medium is 0.565. And so how can we figure out the last part? Well, what we know about probability distribution tables is that these should all add up to 1. So 0.35 plus 0.565 is 0.915. So we're going to do 1 minus 0.915. And that gives us 0.085 as its probability of being large. Okay, and then it asks us to find the expected value. And so we are going to multiply the $4 cost times the probability of it costing that, plus the $10 cost times the probability of it costing that, plus the $12 cost times the probability of it costing that. So 4 times 0.35 plus 10 times 0.565 plus 12 times 0.085. And that gives us 8.07 as our expected value. Now what that means is that we would expect, on average, a fish to cost 8.07. Okay, so the second problem we're going to look at is kind of your very typical 6 to 8 mark cumulative frequency question. So it tells us that there are 80 students that they kind of observed and talked about how much time it took them to complete a task. We can see that there are 80 students as well because the top of this curve is at 80. Sometimes they do try to trick you by making the y-axis go up to 90 even if the curve ends at 80, so that's something to watch for. And it asks you to come up with the median. And so the median is the 50th percentile. And we know that there are 80 students, so half of 80 tells us that the median is the 40th student. And so we can go ahead and go across at 40 and then straight down. And each of those ticks on the x-axis, it looks like it's worth 2. So that means that that is 32 minutes for our median. And then it asks us to find the interquartile range. So that is, again, our Q3 minus our Q1. So that means we're going to look at the 75th percentile of 80, which we know is the 60th student. And we're going to look at the 25th percentile of 80, which we know is the 20th student. So we're going to go up to 60, go over and down, and that is a time of 40 minutes. And we're going to go to the 20th student and go over and down, and that looks like that is the 22nd time, so 22 minutes. And the interquartile range would be 40 minus 22, which is 18 minutes. And the very last part of this problem asks us to complete the frequency table, and so we're basically kind of taking our cumulative frequency graph and going backwards and figuring out the table. So we can go ahead and definitely see these 5 students that are between 0 and 10 minutes, because here's 10. If we went up and over, it does look at approximately half. So we know that right there. So let's go ahead and draw that in. And so we know that that's 5 students right there. And then we don't know how many are between 10 and 20. So we can go ahead and look at 20. If we go up and over, that looks like, let's see, 12, 14, 16 students. Now, it's saying specifically between 10 and 20 as your time. So that's only things in this section right here. So that does not count these 5 that were between 0 and 10. So that means 16 minus 5 means that only 11 students were between 10 and 20. And then to do the section that says between 40 and 50, we're going to do the same exact idea. So we can go up from 40 and over, and up from 50 and over. And so this one is 60. This one looks like 72, 74. And then we're only talking about students between 40 and 50. And so that's only the students between the 60 students that were below and then the 74. So 74 minus 60 gives us 14 students in between. A quick way that we could check this is we could add it all up. 5 plus 11 plus 20 plus 24 plus 14 plus 6. And we knew that there were 80 all along. And when we add it up, we do get 80. So we can be sure that we did that correctly. That's about it for cumulative frequency. They can kind of vary the context of the problem, and they can vary a little bit how they ask the problem, but most of them look very similar to the past 2 questions that we just looked at.